Okay, let's dive into this. Welcome to this explainer on Cambridge Computer Science Paper 2, specifically focusing on the high-stakes battleground of Syllabus Code 9618. Today, we're doing something a little different. We're stepping right into the principal examiner's shoes. You see, memorizing the content, that's really only half the battle. The other half, the exact half that separates the top-tier A-star students from everyone else, is understanding exactly what the examiner is secretly looking for. We are going to decode the precise strategy you need to absolutely dominate your exam. And we're doing it by tearing apart one of the most critical topics on the entire syllabus. So grab your notebooks, get comfortable, because what we cover today is going to completely change how you approach your past papers from here on out. 15%. I just want you to let that number sink in for a second. The topic we're analyzing today, which is 1.3 compression, need for and examples of compression, is an absolute goldmine. It accounts for approximately 15% of the total marks on your Paper 2 exam. That is massive. Literally, that is the difference between an A and a C. It's the difference between missing out on your university offer and securing your top choice. Yet, year after year, the principal examiner reports tell us the exact same story. Candidates are just leaving these easy marks on the table. They're stumbling over the exact same hurdles. But not us. Not today. By the end of this explainer, you're going to see these compression questions not as some terrifying threat, but as your biggest opportunity to just rack up the marks. So here's our syllabus map for today, so you know exactly how we're getting inside the examiner's head. We'll start with the challenge, then dig into some serious examiner warnings, break down the method mark strategy, run an interactive workshop, and finally, piece together the final blueprint. Let's kick things off with Section 1, the challenge. We're going to look at two very different students, Alex and Sam. To really figure out where marks just vanish into thin air, we need to look at how different students attack the exact same paper. Now, you might actually recognize a little bit of yourself in one of these two. First up, we've got Alex. Alex is what we call the data dumper. Alex knows the textbook literally inside out and backwards, but tends to overload every single answer with raw computer science facts while including absolutely zero actual analysis. Then we have Sam. Sam is the speeder. Sam rushes through the paper, panics the second a complex scenario pops up, and completely misses what the command word is actually asking for. They're both working incredibly hard, but they are both bleeding marks. Let's actually compare their answers. Imagine a question that asks you to evaluate the use of lossy compression for streaming a live video feed. Pretty standard, right? Well, Alex writes this massive, beautiful paragraph defining what lossy compression is, explaining how it removes data permanently, and detailing how it differs from lossless compression. It's 100% factually accurate, but it completely ignores the actual streaming live video context. 0 marks for application. Sam, on the other hand, just scribbles down, use lossy because it's faster, entirely missing that the command word evaluate requires you to look at trade-offs, like, say, video quality degradation versus bandwidth savings. This brilliantly illustrates a massive syllabus point. Students severely struggle with applying concepts to unfamiliar contexts. Just rote memorizing what compression is won't save you. The examiner doesn't just want a definition. They want to see you apply that definition to the specific, messy, real-world scenario they've handed you. Moving right along to Section 2, Examiner Warnings. Every single year, after the exams are graded, Cambridge releases principal examiner reports. These documents are literally the grading team telling us exactly why students lost easy marks. Think of them as the ultimate cheat codes to the exam, and yet almost nobody actually reads them. So let's explore what the examiners are desperately begging you to stop doing when it comes to compression and algorithmic problem solving. Here are the top 3 most catastrophic mistakes highlighted by the examiners themselves. Number 1, students completely forget to check overflow and edge cases in compression algorithms. Think about it. When you're compressing a file, what happens if the file is already highly compressed? Or what if it's completely blank? Your algorithm absolutely has to account for that. Number 2, missing boundary conditions. If you're interpreting binary representations, which you have to do for syllabus point 1.3, you have to test the extremes of your data. And number 3, a total lack of specific context. We literally just saw this with Alex. Examiners repeatedly, and I mean repeatedly, note that answers are generic. If the question asks about compressing a medical image where absolutely no data can be lost, and you write a generic answer about compressing a standard selfie on your phone, you get 0 marks. Which brings us to a massive examiner alert, the terminology rule. The reports show that candidates consistently confuse key terminology. The rule here is simple. You must always define your terms before you use them in extended responses. If you're going to drop terms like run-length encoding or dictionary encoding, you need to prove to the examiner that you actually know what those mean in the context of the question before you start evaluating how efficient they are. Locking down your theoretical foundations with precise definitions creates that exact causal relationship the examiner is desperately looking for. Subscribe to our YouTube channel Ace the Exams channel at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now, what's really interesting about this next part is how we actually secure those points. Welcome to Section 3, the Method Mark Strategy. This is an absolutely critical framework for securing process marks, even if your final code or your final calculation completely blows up. You see, the Cambridge syllabus assessment objectives are targeting distinct cognitive domains. They are looking for application and analysis just as much as raw knowledge. So if you mess up a calculation, but your procedural framework is flawless, you can actually still salvage the majority of the marks. You just have to show you're working in a way that speaks the examiner's language. Let's walk step by step through the technical methodology of data interpretation required for 1.3 compression. First, extract from binary. You need to be able to look at a binary representation of data and pull out the patterns. Second, perform calculations. This usually involves calculating the compression ratio, meaning the original file size versus the compressed file size. Third, draw evidence-based conclusions. For example, if your calculation shows a tiny 10% size reduction, you have to ask, is that actually enough to justify the processing overhead? And fourth, test thoroughly. Apply your practical programming skills to design your solution and evaluate its performance. If you structure your answers to clearly hit these 4 steps, you are capturing method marks at every single stage. It's essentially building a safety net against a dumb mathematical error at the very end. Let's do a little red pen, green pen contrast here. Consider a generic compression definition versus a context-specific cross-topic application. A generic definition might earn you 1 mark, maybe. But cross-topic application, that is where the absolute big money is. The principal examiner reports explicitly state that candidates who reference cross-topic connections achieve significantly higher marks. What does that actually mean for you? It means linking compression not just to file size, but to network transmission speeds from the networking part of the syllabus, or data security from the encryption syllabus. When you show the examiner that you understand how compression fits into the entire theoretical architecture of computer science, your mark potential literally shoots up from a standard pass to a distinction. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into the fun stuff. Welcome to Section 4, the Interactive Workshop. We are going to develop some serious algorithmic thinking here, because raw knowledge is totally useless without application. We're going to practice step-by-step decomposition right now. I need you to lean in, really focus, and treat these next few minutes like you are sitting right there in the exam hall. Let's see if you can think like an examiner. We'll kick off with a 60-second visual data scan challenge. Imagine a timer ticking down. You're looking at complex compression data, showing the relationship between calculation complexity and the final evidence-based conclusion. What is the core trend? It's right there. As the algorithmic complexity increases, the file size decreases, sure, but the processing time absolutely spikes. In a real exam, you don't have 10 minutes to stare at a table. You need to rapidly extract that core trend, that vital trade-off between CPU processing time and storage space. That is exactly the analytical takeaway the examiner wants to see you write down. Now listen to this quote straight from the official Cambridge syllabus. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. That is the golden rule, guys. So let's play a game called Find the Flaw. Let's say a student writes, run length encoding is best for text files because it replaces repeating characters with a frequency value. What's the flaw there? Well, the knowledge is technically correct, but it completely fails in an unfamiliar context if that specific text file doesn't actually have any repeating characters. The student failed to evaluate the data structure. They didn't exhibit that connected understanding. So how do we fix that? We use the Peel framework. This is your ultimate weapon for our 30-second speed writing challenge. Point, evidence, explanation, link. Let's break it down. Point, lossless compression is required for executable files. Evidence, lossless algorithms like dictionary encoding perfectly reconstruct the original data. Explanation. This is absolutely vital because a single lost bit in an executable file will cause the entire program to crash. And finally, link it back.
Therefore, despite lower compression ratios, lossless is the only viable method for software distribution. Boom! If you write one perfect examiner-approved paragraph using this framework, you are virtually guaranteed to hit those top marking bands. Let's move to the final piece of the puzzle and see how this all builds together. Section 5, the final blueprint. We are now entering the absolute mastery level of evaluative thinking needed for top-tier marks. You've seen the mistakes, you've learned the procedural framework, and you've practiced the peel structure. Now, we pull the whole shebang together into an evaluation matrix that you can overlay onto literally any computer science problem you face on paper 2.
Here is the matrix. Top-scoring candidates demonstrate critical analysis by considering multiple solutions and analyzing the trade-offs. You must evaluate the quality of an algorithm based on these specific pillars. First, time complexity. How long does the compression actually take to execute? Second, space complexity. How much memory does the algorithm need while it's running? And third, edge cases and performance effect. What happens when the algorithm hits a worst-case scenario, like an entirely random data string with absolutely zero repeating patterns? When you acknowledge these limitations and justify your decisions with this level of technical evidence, you aren't just answering a question anymore, you are proving total mastery of the subject. Let's recap with the ultimate cheat sheet, the 3 ironclad rules that form your complete computer science answering system. Rule 1, command word decoding. Never, ever answer an evaluate question with a describe answer. Always decode what they're actually asking. Rule 2, peel framework application. Always structure those extended responses with point, evidence, explanation, and link. It guarantees you hit the assessment objectives for application and analysis. And Rule 3, time management matrix. Use the method mark strategy to show your procedural framework step by step so you capture marks even if you run out of time to perfect that final code. Stick to these 3 rules, and I promise you, you will completely transform your exam performance. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep pushing, keep practicing, and I will see you in the next explainer.